Okay, so we've seen recently that we can manipulate equations nicely. We're now going to look at this thing called solving simultaneous equations. So simultaneous is just the proper word for at the same time. So we have two equations here. There are two variables in each equation, which means there are lots of pairs of numbers x and y that can make this combination add up to 41. And you know that from when we have coordinates making a line. So there are infinitely many solutions to this one equation. There are some values of x and y that make 41. There are also a whole bunch of values that when they're done in this combination, x and y can get to 29. But is there a pair of values that these are both true at the same time? So one of the ways to do that is to use this elimination method that we started looking at last time. So to begin with, I'm going to label these equations. This can be called equation P. This can be called equation Q. So you might recall one of the things in the last video made one of the letters go away. It was eliminated. So by cleverly selecting to add or subtract, we can make something disappear. You will notice that we have the same number of x's in both equations here. So if I subtract them, 3 take away 3 is 0, so something will have gone. So what we can do here is P take away Q. And that's a choice. You could have chosen to add these, or you could have chosen to do Q take away P. One of the choices is always easiest. So P take away Q, 3 take away 3 is nothing. Brilliant, the x's have gone. 5y take away 2y is 3y. And 41 take away 29 is 12. So that's where we left it last video. We're now going to carry on and try and work out what this tells us. So we've now got a really simple equation where 3y equals 12. We should know that to solve that equation, we divide by 3, which leaves us behind that y is 4. That's kind of useful, but you'll notice there are two letters here, x and y. We haven't found x yet. But we know that x is linked to y in this way, and we know it's linked to y in this way. You can pick either link to care about. I think equation Q looks slightly simpler. So what we're going to do is substitute y into Q. So we know that y is worth 4. So if we reread equation Q, we've got 3 x's at the start. We've got 2 y's. Well, y is worth 4, so 2 y's is actually 8. And again, we've got what is a fairly simple equation, the type you've been solving for a few years. So we start by taking 8 away from both sides. And that gives us 3x equals 21. And then we divide by 3. So we get x is 7. So we can check that now. 3 times x is 21. 2 times y is 8. 21 add 8 is 29. It works there. 3 times x is 21. 5 times y is 20. 21 and 20 is 41. So those are the values that make these both true. It's helpful just to write the answer clearer at the end to make it easy for an examiner, or for anybody you want to share the answer with to make it easy to find. So that is the solution to this pair of equations. This pair of equations are both true at those x and y values, so we have solved them simultaneously. Let's try one more a little quicker. Let's call this equation A, let's call this equation B. The x's don't match up this time, but the y's don't exactly match up, but they're the same size. So 2 take away negative 2, because that is functional, this is a negative, it's a take away. 2 take away negative 2 doesn't get us 0, but adding them will cancel out nicely. So if we do equation A, add equation B, we will get 7x and 5x is 12x. We will get 2 add negative 2 is nothing. 1 add 11 is 12. So here, by adding, we got the positive and negative to cancel out nicely. So divide by 12, x is 1. So we know that x is 1. Again, we're going to do our substitution step. So substitute into, do you care which equation looks easier? I think A is slightly easier here, but that's just a free choice again. If x is worth 1, that means that in A, this 7x is worth 7, plus 2y is 1. So that is just reading equation A left to right, but I know what x is worth. So this is 7 ones, 7, plus 2y is 1. Take 7 from both sides, just like you would any other three-term equation. Gets us negative 6. Divide by 2, so y is actually a negative number, it's negative 3. And again, write the answer clearly, x is 1, y is negative 3. So, that is the start of solving some simple pairs of simultaneous equations. Sometimes you will get answers that are fractions, that's allowed, fractions are numbers too. Don't panic about that, but you can always check if they work by putting them back through your equations at the start. Enjoy!